Okay, guys, this is our final answer or final example problem that I'm going to do for now. And it is a little bit of a challenge, so that's why I wanted to do it with you so that you can see how in-depth some of these problems can get. So let's go step by step on this one as well. So let's start at the beginning. First step is to simplify, rearrange, and remove a greatest common factor. So if we take a look at this, simplify means that we need to combine like terms and there's nothing here to combine. Rearrange means that we don't have it in standard form, but it is in standard form, so we can move on. And the final step is to remove the GCF. Okay, this does have a greatest common factor. If you look, these are all divisible by 5, so 5 is going to be our greatest common factor. The t is not present in all of the terms, so we cannot take a t out. So we're going to take the 5 out. And when I take it out, I'm going to divide each of these terms by the 5 to find out what I'm left with. So 5t to the 4th divided by 5 leaves me with just t to the 4th. Negative 25t squared divided by 5 is negative 5t squared. And 20 divided by 5 is 4. Okay. Now this is the first time that we've come across a trinomial that had a highest exponent greater than 2 that we didn't factor out. So we need to check this out and see if it's going to work. Okay, so once we've removed our greatest common factor, we travel down to trinomial. We're going to do a factor test to see if it can be factored. If it can, we'll do backwards FOIL. If it can't, then we will call it prime. Okay, so if we look at this, we're going to do the b squared minus 4ac. So a again here is 1, b is right here, it's a negative 5, and c is this last term over here, it's 4. So plug it in, b is negative 5 squared minus 4, a is 1, and c is 4. So if we use our calculator, all right, we're going to plug in this negative 5 in parentheses and square it. Sorry, you can't see that. There you go. Then we're going to do negative 4 multiplied by 1 multiplied by 4 and press enter, and we get 9. 9 is a square. It's 3 squared. So we can factor this. So we're going to go ahead and factor this out with our backwards FOIL method. So backwards FOIL, here are the steps again. First step is to find two factors whose product is equal to a times c and the sum is equal to b. So a times c in this case is 1 times 4, which is 4, and b is negative 5. So I want two numbers that multiply to get 4 and add to get negative 5. So 1 times 4 is 4, 2 times 2 is 4. But if I add those together, okay, so 1 plus 4 is 5, and 2 plus 2 is 4. Neither of those equal negative 5. So we're going to have to think of factors in terms of negatives. So if I were to multiply negative 2 times negative 2, I could still get 4. And if I multiply negative 1 times negative 4, the two negatives cancel and it is still a positive 4. Okay, so let's add those together and see if we get anything that works. So negative 2 plus negative 2 is negative 4, and negative 1 plus negative 4 is negative 5. So we do have these two numbers right here. Negative 1 times negative 4 is a positive 4, but when you add them together, you get a negative 5. So these are the two numbers that we're going to use, negative 1 and negative 4. Okay, so that's step 1. Step 2, we expand the trinomial into a 4-term polynomial and group the terms into 2 binomials. So let's show what that looks like. Remember, 5 is still out here. We haven't forgotten about him. But here we have t to the 4th minus 5t squared plus 4. Okay, and we want to expand this middle term. We want to turn it into these two numbers. Negative 5 is going to become negative 1 and negative 4. Okay, make sure you can see that whole paper. So negative 5 becomes negative 1 and negative 4. So 5 is still out here, the t to the fourth is still here, and this plus 4 is still here. But we're going to expand negative 5 to be negative t squared and negative 4t squared. So if I combine those back together, they're like terms, I would still get negative 5. So I haven't changed the original polynomial. All I've done is expand it into some terms that I can work with. Okay, so I haven't changed anything. All I've done is expanded it. It's still the same original polynomial. If I multiply all this back out and add that together and do everything that I would do, I would still end up with this original polynomial, which is exactly what we're trying to do. Okay, so now that I have it expanded, it tells me that I need to group the terms into two binomials. So 5 is still out here, haven't forgot about him. But I'm going to take this and I'm going to turn it into t to the fourth minus t squared and negative 4t squared plus 4. Okay, so t to the fourth minus t squared, negative 4t squared plus 4. All I did was put parentheses around these and just split it. Okay, all right. Now that I have it split, we move on to the third step. And the third step is to remove the greatest common factors. So 5 is still out here, haven't forgot about him. Greatest common factor between t to the fourth and t squared is t squared. So if I take it out, I'm left with t squared minus 1. T to the fourth divided by t squared is t squared. Negative t squared divided by t squared is negative 1. Okay. Then out here, my greatest common factor is 4, but I don't want to be left with a negative here. So I'm going to take out negative 4. And if I take out negative 4, negative 4t squared divided by negative 4 is just t squared, and 4 divided by negative 4 is negative 1. Okay? And then the final step is to separate what we have into two binomial factors. So I'm going to separate it. I have 5 still here. T squared minus 1 is the common factor. And then what's left over is t squared minus 4. So t squared minus 1 and t squared minus 4 is what we're left with. Now, it does tell us in our notes that if powers are 1, we're probably done. Well, our powers are not 1, so we need to run back through and make sure that we have done everything that we need to do. So that means we run back through the original and make sure that we don't need to simplify, rearrange, or remove a greatest common factor in either of these terms, and we don't. So then we can move down to the binomials because that's what we're left with. And we need to decide if any of these are difference of squares, difference of cubes, or a sum of cubes. And if they're not, then we're done. But if they are, then we need to keep factoring. So let's look real quickly. Difference of squares. Difference, it means we're dealing with subtraction. It means the powers are divisible by 2, and then we're dealing with numeric squares. 1, 4, 9, 16, 25, 36, etc. If it factors, if it's a difference of squares, it's going to factor into two binomials. So let's look and see what we have here. 5 is just a number, all right? So we're not worried about it. It's factored. T squared minus 1 is a binomial. It's got subtraction. That power is divisible by 2, and 1 is a square. So this is a difference of squares. We can factor this into two binomials. Over here, t squared minus 4 also is subtraction, also has a power divisible by 2, and 4 is also a square. So here, both of these are difference of squares. So that means we have to factor both of these into two binomials each. So again, this is going to get a little bit extensive. So let's go ahead and work these out. All right, if you remember the pattern here, it's a squared minus b squared. Okay, that's the difference of squares, and it's factored into a minus b and a plus b. So we take the square root of this and the square root of this, okay, and then we just change the signs. That's all that we're doing to factor these. So let's not forget 5 is still out here. He's still part of our final answer. This t squared minus 1 is going to get factored into two binomials, okay, remember that. We take the square root of t squared, which is t. We take the square root of 1, which is 1. Okay, we use the same sign and then we switch to the opposite sign. So that is factored. All right, but we still have this t squared minus 4. it also needs to be broken into two binomials. So 5 is still part of this, t minus 1 is still part of this, t plus 1 is still part of this, but we also have to factor this. So t squared divided by the square root of t squared is t, and the square root of 4 is 2. We use the same sign, and then we use the opposite sign, okay? Now our powers are 1. Now we're probably done, but we do have to prove ourselves, which is going to take some time, okay? So this is the answer that we think is final, but let's prove it. Okay, so 5 times t minus 1 times t plus 1 times t minus 2 times t plus 2. Oops, that is a 2, not a z. All right, so I'm going to go ahead and multiply these back together because if we did it correctly, they should have some zeroing out of those middle terms, and it should keep it from getting too messy. So I'm going to multiply first, is going to be t squared, outer, t times 1 is t, inner is going to be negative t, and the last 2 is going to be negative 1. Positive t and negative t zeroes out, okay? Over here, we're going to do the same thing. I'm going to do first, t times t is t squared, outer, t times 2 is 2t, inner, negative 2 times t is negative 2t, and the last, negative 2 times 2 is negative 4. Positive 2 and a negative 2 zeroes out, so what we're left with here is 5 times t squared minus 1 times t squared minus 4. I'm going to go ahead and multiply these two together again. So 5 hasn't been forgotten. T squared times t squared is t to the 4th, so those are my first terms. My outer terms, t squared times negative 4 is negative 4t squared. Inner terms, negative 1 times t squared is negative t squared. And the last two terms, negative 1 times negative 4 is positive 4. Once we combine these like terms, we have 5 times t to the 4th, and then this negative 4 and negative 1 becomes negative 5t squared. And the last step, sorry, I know you can hardly see this, is we multiply this 5 by everything. So 5 times t to the 4th is 5t to the 4th. 5 times negative 5t squared is negative 25t squared. And 5 times 4 is 20, okay? And if we go back to the very top here, 5t to the 4th minus 25t squared plus 20 is exactly what we started with. So yes, this, all of it, is our final answer. 5 multiplied by t minus 1 multiplied by t plus 1 multiplied by t minus 2 multiplied by t plus 2. Okay, so that was a lot to take in. This is a odd example that really factors out quite a bit. You won't see a lot of that, but I did want you to have at least one example that you had seen that really that went back through several times into the process. It's a difficult situation or difficult question just because it does factor so much. But I just wanted you to see an example of it.